Module 2, Lesson 14, Modeling Relationships with a Line. This is day 2. Today we're going to determine the residual of a set of data. Open your workbook to page 85. We're starting with example 3, residuals. This is about halfway down the page. One way to think about how useful a line is for describing a relationship between two variables is to use the line to predict the y values for the points in the scatter plot. These predicted values could be compared to the actual y values. For example, the first data point in the table represents a man with a shoe length of 12.6 inches and a height of 74 inches. If you use the line y equals 25.3 plus 3.66x to predict the man's height, you would get, so we take the equation, plug in 12.6, you get 71.42. His predicted height would be 71.42 inches. Because his actual height was 74 inches, you can calculate the prediction error by subtracting the predicted value from the actual value. The prediction error is called the residual. Okay, so that's a definition you need to know. The prediction error is called the residual. So residual is prediction error. So a residual is called the prediction error. I know it's right there, but you should write it down. Writing is one more way to help you remember what something is. Okay, so to calculate the residual, you take the actual y value and subtract the predicted y value. So you take the actual, which is actual was 74 inches, and you subtract the predicted y value, which is the answer that you get from the equation, the best fit line. And when you subtract those two in this case, we get 2.58. So that's how much difference there was between the actual and the predicted value, 2.58 inches. Okay, exercises 8 through 10. For the line y equals 25.3 plus 3.668, let's calculate some missing numbers here. Okay, so we have our shoe length and our height. We're going to find our predicted values. The predicted value is what you get when you plug in x into the equation. Okay, so we're going to take, for this first missing value right here, we're going to take our equation and we're going to plug in x, 12.22. So taking my calculator, get it off the screen. Second in mode, whenever you're on a screen you don't want to be on. And I'm going to plug in my calculator the x value. This is x. X is equal to 12.22. Plug that right into my calculator. Into my equation. So 25.3 plus 3.66 times 12.2 equals 69.95. They took them out two places, so I'll say 69.95. Okay, that's the predicted value. Now to get the residual, you take the actual value, which is y. So the actual value, which is y, minus the predicted value. So in this case, I'm going to take, let's see, 71. 71, subtract 69, oops, 0.95. And I got 1.05. That's my residual. Okay, so going down this next one, I'm looking for the residual. I want to find the residual. They already gave me the predicted value, so I'm going to take my actual, which is 68, and subtract off my 67.02. Okay, so 68 minus 67.02. And that's 0.98. Okay, this next one. Again, this time I want to find out this number here. So find that number there. Oops, I'm going to plug in x into the equation to get that answer. Can't put it there, let's see. You make yourself any kind of extra notes so that way when you're looking back you can remember what you did. Okay, so I'm plugging in x. Oops, my x for this one is 12.2. So, plugging in 12.2, so 25.3 plus 3.66 times 12.2 equals, and I got 69.95. Was that the same number we plugged in earlier? Yes, it was. Same answer. Okay, but the residual is different because the height, the actual was different. Okay, so there's our three answers. So we got the rest of the table filled in. Okay, now it says, what is the residual in the table, what is the residual in the table's first row positive and the residual, that should probably say y. That should probably say y. Y is the residual in the table's first row positive and y is it negative in the second row. Okay, so the reason why this one came out positive is because the predicted value came out smaller than the actual value. Oops, I missed one. And this one came out negative, I'm guessing, because this one's going to come out to be bigger. I'm going to plug that one in real quick. So I'm going to plug in 11.85, or 11.8. So 25.3 plus 3.66 times 11.8. And that's coming out to 68.4. Oh. Okay, what was it again? 68.48. Yes, see that's coming out higher than the predicted is coming out higher. So if the predicted is, so in the first row it came out to be positive. when the predicted value say for instance these two, when the predicted value is smaller than the actual value, and it'll come out negative when the predicted is greater than, oops, I'm writing that twice, the actual. Okay, next question says, what is the sum of the residuals? And then why does that number seem to come out close to 0? So the next thing we need to do is we need to add up all of these numbers that we have here. So we're going to add those all up, total it. Right, so 2.58 plus negative 3.49 plus 1.05 plus negative 0.76 plus negative 0.95 plus 0.98 plus negative 2.15 plus negative 0.95 plus 0.58 plus 2.51. And that's coming out to negative 0.6. Okay, so we just added up a whole bunch of numbers. So the sum came out to negative 0.6. And they asked us, why did we get a number close to 0 for that sum? And what does this mean for all of the, does this mean that all of the residuals were close to 0? Okay, so the reason why we got a number that was really close to 0 is because there were enough positives and negatives that they almost canceled each other out. And then it says, does this mean that all of the residuals were close to 0? And not necessarily. There were some numbers that weren't necessarily close to 0. Some of them were, but like we got 2.51, for example, negative 3.49. They're not all necessarily close to 0. Some of them were. Okay, when you use the line to describe the relationship between two numerical variables, the best line is the line that makes the residuals as small as possible overall. Okay, so we want the residuals to be as small as possible overall. If the residuals tend to be small, what does that say about the best fit line? Well, if the residuals are small, then we know that the line is going to be the best line. The most common choice for the best line is the line that makes the sum of the square residuals as small as possible. So we're now going to add a column to the right of the table in exercise 8, and we're going to calculate the square of the residual. Okay, so go back to this column here, and we're going to add one that's called the squared residual. And we're going to square all of these numbers. And when you do that, then you're going to total it, and you're going to find, in this case, when you square them, remember that you must put parentheses around negative numbers. So for example, and I'm not going to do all of these, 2.58, oops, I forgot to square it, 2.58 squared, that one comes out to 6.65. Okay, but when you do the negative number, you have to make sure you put it in parentheses. So parentheses, negative 3.49 parentheses, and then square. And you can see why I don't like using this calculator. My 3 didn't come up. Okay, parentheses, negative 3.49 parentheses, and then square it. And I got 12.18. And you'd keep going all the way down, and then you would actually total that one also. Okay, so keep filling in the rest of that. And it says, why do we use the squared residuals instead of just the sum of the residuals? And the reason why we use the squared residuals is because you won't have any negatives. So they're not going to cancel each other out. Okay, so that's the reason why we use the squared residuals. So then you can keep on going with that column, and you can add them up, and then you can find out what that sum would be. And that number, we also want that to be as small as possible. It won't be close to 0 because you're going to be adding up a whole bunch of numbers, but we do want it to come out to be as small as possible. There's a couple more questions in the book about slope, and I think I'm missing those questions. I'm just going to add them on because they're really important questions. And you can do 14, I didn't finish those. But I want to, or question 13. We skipped yesterday. This is about the shoe links. Let's see, I'm going to find them again real quick. This question's 15 and 16. Okay, going over to page 88. So you can answer question 13. Finish the chart and adding on the square residuals. Then I want you to go over to page 88. And I want to talk more about our equation, y equals 25.3 plus 3.66x. I want to look specifically at, where was it? Question 16. First, 16 says, give an interpretation of the slope. Well, in our equation, remember, it's y equals mx plus b. This one's written a little backwards. Which part's the m? M is right here because there's our x. So m is 3.66. If we put that over 1 to make it into a fraction, we always want our slope to be a fraction, then we can interpret that. And this was about shoe length of, I think it was men. Yeah, and the slope is always rise over run. And rise is the going up and down, so the y values, which is the height, over the run, which is the x values, and that would be the shoe length. Oh, still spelled it wrong. TH. There we go. So what this slope is saying, as far as an interpretation of the slope, it's saying that for every 1 inch that the shoe length increases, the guy's height is increasing by 3.66 inches. So for every 1 inch, the shoe length increases the guy's height, or the men's height, increases by 3.66 inches. Okay, so that's what they mean by give an interpretation of the slope. Now the other number is the y-intercept, but that number doesn't actually make sense, which is what question 17 is asking. Why doesn't that question make sense? Well, the y-intercept is where something starts. So question 17 says, explain why the y-intercept doesn't make sense for the predicted height. Well, a guy's height doesn't start at 25.3 inches. So that's it for today's lesson.